Hi, our lecture today is about estimating OLS model using EViews. This is the Excel sheet for the data under consideration. We have 5 main variables over the period from 1990 to 2020. Let's start with data entry. Open the program, the first step, and then we have to select create a new EViews workfile. So you have either to choose create new workfile or open an existing file. Let's start with a new workfile. From this box, first we have to select whether our data is cross-sectional data or time series data or panel data. With respect to cross-sectional data, it will be unstructured or undated. And with respect to time series data, it will be dated or regular frequency. And finally, balanced panel data for panel data. In our case, it is a time series data, so we have to choose dated regular frequency. And then we have to select whether our data are annual or semi-annual or quarterly, monthly, and so on. So in our case, our data is annual data. And then we have to identify the start date and the end date. We are going to start from 1990 to 2020. And then OK. From this box, you can identify that there is a new work file. Its name is untitled. After saving the file with any name, you can find that this name will change to the new name. And the range under consideration is from 1990 to 2020, which is 31 observations. Now we have to import the data to the file or copy and paste the data for the file. If you would like to copy and paste the data, so you can write in the command part the word data and enter. So you have a sheet like the Excel sheet. You have to copy and paste data here. Or you can import the Excel sheet as it is. From file, import from file, and then you have to select the Excel sheet. Open. You have to define which sheet in the Excel sheet is sheet number 1 or 2 or 3 and so on. The default is sheet 1, okay? And then next, you don't have to change anything, okay? In step number 4, this is the structure of the data. It's dated data, annual, okay, and then you have to identify the start date, which is 1990. So now you can find that here there is 1990, 1991, 1992, and this is the 5 main variables and their names. Finish. Yes. Now you can find that this is EX, FDI, GDP growth rate, inflation, and unemployment. So these are the 5 main variables. If you are going to double click any one of them, you can find the data which was found in the Excel sheet. This is how to import or add the data to the EViews file. Now we would like to estimate the model. From quick estimate equation, and then you have to write first the dependent variable. Let's assume that in our case the dependent variable is GDP growth rate. So it will be GDP, which is GDP growth rate, space. There is a constant in the equation, so we have to add C for the intercept, and this is common. It's common. Usually you have to use C. You cannot use any other notation for the intercept. And then you have to add the independent variables: FDI, exchange rate, inflation rate, unemployment. Okay. Method. You have to select the method. As we said for today, that our lecture is about estimating the model using OLS, or ordinary least square, which is the default of the program, so we don't have to change anything about this. Also, we can change the sample under consideration. Say, for example, we would like to be from 2020, sorry, from 2000 to 2020, not from 1990. So here you can change the sample if you would like. And then, okay, this is the output. Shows that there are 30 observations after adjustment. This is the value of the coefficients, which is the value of the parameters. Okay. This is the constant or the intercept, and this is the value of FDI. Let's assume that let's say that FDI has a positive impact on GDP growth rate. If FDI increases by 1 unit, GDP growth rate will increase by 0.37 units. Okay, and so on. The same with respect to exchange rate. According to these results, there is a negative relationship between exchange rate and GDP growth rate, and so on. And then we have the standard error, the t value of t, to test the significance of the variables, and the probability. So instead of using t, you can use probability. If the value of probability is greater than 0.05, so we are going to accept H node, which states that the variable is insignificant or has no significant impact on the dependent variable. Then you have R squared, which shows the variation in the model. By how much the model explains the variation in the dependent variable. Here in our example, for example, the model explains 67.5% of the variation in GDP growth rate, and the rest will be accounted for the error term. Okay, and there are a number of other tests or ratios that can be used based on your study. This is the end of our lecture today. Thank you, and see you next lecture.